I'm Guillermo Marin, and I am the lead of the Visualization and Storytelling Research Line here at the Barcelona Supercomputing Center. The Barcelona Supercomputing Center is a publicly funded research institution that is Spain's national supercomputing facility. It is the home to one of the most powerful supercomputers in the world, which is called MareNostrum.
I'm Marta Esteban Fernandez. I'm a research engineer at the Barcelona Supercomputing Center in the Data Visualization Group. The Barcelona Supercomputing Center is a research facility in Spain that currently hosts the MareNostrum 5 supercomputer, that is the 11th most powerful computer in the world, and is used by scientists across many fields to foster science. MareNostrum 5 is a pre-scale supercomputer composed of two partitions. The general partition made of more than 6,000 nodes that can operate together like a single machine, and another partition made of GPUs that can also operate in parallel.
So a supercomputer is like having a lot of regular computers plugged together. They communicate to each other. So you can have a very big and complex problem, like for instance simulating the human heart or an airplane, that cannot fit in a single computer. So what you do is split that problem into smaller pieces and have the supercomputer, different nodes in the supercomputer, compute that individually, but in a way that they know what the other one is doing in order to maintain consistency in how they compute that problem. An example of this would be the simulation of a tumorous cell, a cancer growing, and this was run in MareNostrum and it took 15 days. This same simulation in a workstation would have taken 16 years. When researchers and scientists use MareNostrum to run these very complex problems, they also produce a lot of data. And what me and my team do is find solutions in order to visualize that data. The main way in which we approach this is by using Houdini to produce high-end visualizations of these simulation results. A few examples of this are visualizations that we've produced about the human heart, about pollutants traveling around the atmosphere, digital twins of cities, cars, airplanes, tumor cells, drug screenings, and so on and so forth. So a team here at the BSc works in developing codes to improve the simulation of airplanes, and they developed this new simulation code that allows to perform larger simulations, larger problems, in more efficient ways. The main objective of the scientific project is to develop a code that allows not only supercomputing facilities but companies to run these simulations in order to be able to optimize the design of airplanes in a much more efficient way. So this is a challenge that we have not only with the plane but in general. That is, for these very complex big simulations, there is a lot of data produced. And our challenge is how do we ingest this into Houdini in order to visualize it. One of our most active lines here is to convert this data into VDV. Because if we do this, we can leverage not only the OpenVDB format inside Houdini, but also all the other tools that Houdini has for data manipulation. So we are also involved in a big European initiative to create a new generation model of the Earth that has a resolution of up to 3 kilometers. And this model will allow scientists to run simulations on things that were not run as accurately in previous models, like for instance resolving storms. The use of these models is to run simulations of what will happen with the climate of our planet in the future. Using Houdini in this project was very important because of the tight integration of OpenVDB inside Houdini. And also it's very important using Houdini because we can leverage all the endless possibilities that it has for manipulating data. Houdini is a fantastic tool for us because it's very data-centered. We can track what happens to the original data when we load it, all the way through the final render. So I'm very excited about what will the future bring in terms of using Houdini in supercomputing environments and data visualization. The other way in which I think this will bring interesting things is that Houdini can potentially be used as a scientific visualization tool, so it can be adopted also by the scientific community in order to produce visualizations that are not only beautiful but also meaningful.